is a zebra white with black stripes? Or black with white stripes? Well, it turns out that they're actually black with white stripes, but it's the reason why that's much more interesting. To understand this, we have to go back to the 1950s and meet Alan Turing. Now, you may have already heard his name before. He is widely known as the father of modern computer science. But one aspect about his life that many people didn't understand is that he was actually super interested in biology. In one of his papers, titled The Chemical Basis of Morphogenesis, he hypothesizes how patterns, such as the stripes on a zebra, arise in nature. He called it the reaction diffusion system, and it goes something like this. Let's say that you zoom way into a developing zebra embryo and you see all of its cells. They might look something a little like these snowballs on the table. Now, all of these cells aren't the same. Some of them have a chemical or a protein called an activator. The activator tells the cell and all the cells around it to create a specific pigment, in this case, blue pigment. But the activator also creates an inhibitor, which is basically supposed to tell the cell, wait, no, don't do that. However, the activator command to turn blue comes before the inhibitor's veto of that order, and the cells just can't undo the pigment they created, so they stay blue. However, the inhibitor moves much faster than the activator, so it can get to the cells further out quicker and tell them not to turn blue. Eventually, the inhibitor completely traps the activator, resulting in a blue spot like this. Now, you may be thinking, hold on, that's a spot, not a stripe. How did the stripes on a zebra get formed? Well, Turing had a hypothesis of how this happened, but modern research actually showed that it depends on when in the embryo development process it occurs. For example, in zebras, it occurs very, very early on, before the actual shape of the zebra has been formed. And so that one spot morphs along the body of the zebra as it was being formed, turning the spot into a stripe. Now, Turing patterns didn't just solve whether a zebra is black with white stripes or white with black stripes. They can actually be found throughout the biological world. Just by changing a couple parameters like the shape of the animal or the time of development that it occurs, you can get patterns that range from the spots on a leopard to the stripes on an angelfish. Scientists recently discovered that even the development of fingers follows a Turing-like pattern, activating and inhibiting the gene that creates these digits. By understanding how Turing patterns work, you can understand so much about the biological world and how beautiful patterns, as well as useful body parts, are made.